Hi dear students, today we are going to start with the module 5 of data mining and data warehousing. So, that is clustering analysis. Today we will see the different topics and different modules covered in clustering analysis. So, in clustering analysis we are going to see what is clustering analysis, its overview. K means clustering algorithm, agglomerative hierarchical clustering, then density based scan algorithm, cluster evaluation, density based clustering, graph based clustering and scalable clustering algorithms. We will see one by one. So, first coming to the introduction of what is a cluster or clustering analysis. So, what is a cluster? So, cluster is nothing but a group of similar type of the objects is called as a cluster. Okay, so, if an object belongs to having the same properties and same attributes, we call them into a one cluster, and unrelated objects will be in the another cluster. So, clustering analysis is nothing but finding group of the objects that have the objects in a group will be similar. So, here I need to find out the objects that have such that the objects will be similar, or the objects with the same properties will be kept in a one group, or we call it as a related objects. So, related objects. So, what is clustering analysis? Finding group of the objects such that objects in a group will be similar to one another and different from the others. So, the objects in one group should be different from the other objects, or we call them as unrelated objects. Okay. So, here, so whenever you take a group of the objects, so greater the similarity within the group, then greater the difference between the groups. So, when you combine different objects with different similarities into different groups, so in one group all the objects will be very much similar. So, greater the similarity between the objects of one cluster, then greater the difference will be between the groups. So, the more better or more distinct clustering we can do. So, I need to, in a clustering analysis, what I need to do is I need to cluster the objects of one type in, I need to group the objects of one type into one group and objects of the other type into the another group. So, what clustering analysis does? Clustering analysis divides data into the groups or the clusters that are meaningful, useful or both. So, clustering analysis divides. What clustering analysis does? Clustering analysis divides data into groups that are meaningful, useful or both. In the context of understanding data, clusters are potential classes, and cluster analysis is the study of technique for automatically finding the classes. So, why a clustering analysis is essential, or why we need to group the objects of a similar type in one group. So, whenever we have a huge amount of data available in data mining, so if I want to understand the data into data, then what I need to do? I need to differentiate, or I need to remove the data that belongs to one group, and I need to separate the data that belongs to the other group. So, in the context of understanding clusters, clusters are potential classes. So, if you want to understand the data which belongs to different classes or different groups, then clustering is most important. So, clustering analysis is the technique for automatically finding out the classes. Next, coming to the where clustering applications. What are the applications of a clustering? So, first one is applications of the clustering in biology. So, biologists have applied clustering is to analyze the large amount of genetic information that are now available. So, now in biology I need to group the objects, and whenever I want to analyze the genetic information, okay, then there we can use the clustering algorithms, or we can use the clustering in order to differentiate the genes that belong to the similar group, and I need to differentiate the genes that belongs to a different group. For example, clustering has been used to find the group of genes that have similar functions. Second application of a clustering is information retrieval. So, the World Wide Web. So, now today World Wide Web contains billions of the web pages, and so whenever you put a query to a search engine, what happens? The search engine will give you thousands of results. So, now out of this, which one belongs to similar pages, which are the pages that does not belong to what you are searching. So, there we can use clustering. So, clustering can be used to group these search results into a smaller number of clusters. Means, so whenever you put a query onto a search engine, so the clustering can be applied to group the pages that belong to a similar type of the search and small number of clusters, then we can analyze those web pages. So, clustering can be used to group these search results into a smaller number of clusters, each of which can capture a particular aspect of the query. So, next coming to the climate. So, in climate, understanding the Earth's climate is also an important application where we are applying a clustering. Understanding the Earth's climate requires finding the patterns in the atmosphere and ocean. So, now whenever we want to understand the Earth's climate, what is required? It is required to find the patterns of the atmosphere as well as the oceans. Okay, so, clustering analysis can be applied to find the patterns in the atmospheric pressure of a polar regions and or of the ocean that have a significant impact on the land climate. So, then coming to the another application of clustering, psychology and medicine. An illness or a condition frequently has a number of variations, and clustering analysis can be used to identify these different subcategories. Okay, so whenever so in order to differentiate one disease from another disease, okay, so there also we can use the clustering analysis in order to identify illness or different conditions that have different number of variations. Next, coming to the business. So, business collect a large amount of information on a current and potential customers. So, now today, so if you see business, so whenever you perform an online shopping or whenever you search engine for a particular product, all your information, all your search results are being collected, and all the information related to you is stored in the form of a database. So, there clustering analysis can be used to segment customers into a small number of groups for additional analysis and marketing activities. So, in order to market a particular product, I need to find out the customers which are in need of that particular product. So, if I am interested in a particular product, so then only I will be consider, for example, I am interested in mobiles more, then I will be put into a list of the customers, or I will be put into a group of the people or a cluster where all the people are interested in buying a mobile or interested in buying a mobile that are having good number of features. Okay. So, these are the different applications of the clustering analysis. Next, coming to the clustering, what are the different types of clustering? A clustering is a set of a cluster. So, what is a clustering now? Cluster is a group of similar objects which are similar to one another into the group and unrelated to the other groups. So, a clustering is a set of the clusters. Okay, so, important distinction between hierarchical and partitional set of the clusters. So, now we have two different types of the clustering, one is hierarchical clustering and another is partitional clustering. Okay, so, now consider first one, a partitional clustering, a division of data objects into a non-overlapping subsets cluster such that each data object is an exactly one subset. So, here, so objects or the different items are grouped into a particular group such that they are non-overlapping, or they are non-overlapping subsets, means each group is different from one another such that an object is an exactly in one subset. So, consider for example, if I have 5 different clusters. So, if one object belong to cluster number 1, it should belong to only cluster number 1, it should not be a part of the cluster number 2, 3, 4 and 5, means it should not have the properties of the objects which are present in cluster number 2, 3, 4 and 5. Next one is hierarchical clustering, a set of nested cluster organized as a hierarchical tree. So, now here this is bit different. So, now here a set of nested clusters. So, you know what is a nested clusters. So, our nested clusters organized as a hierarchical tree. So, now here the clusters are arranged in the form of an hierarchical tree. Okay, now coming to the next concept of what are the different types of the clusters. So, different types of the, so now here types of clustering, one is partitional clustering, another is hierarchical clustering. Next, coming to the types of the cluster, what are the different types of the clusters? One is well separated cluster, center based cluster, contiguous clusters, density based clusters, property or conceptual clusters. So, now what is, let us see the first one. What is a well separated cluster? A cluster is a set of points such that any point in a cluster is closer or more similar to every other point in the cluster than to any other point, than to any point not in the cluster. So, now example, if you take any point in this cluster, the objects or the points in this cluster are very similar to this cluster only. The points or the objects in this cluster are not related to any other cluster. They are not having properties they are not having any properties that are present into this cluster. So, the properties of this cluster are totally different and properties of this clusters are totally different, and there is a huge distinction between these two clusters. There is no similarity, and there is a huge amount or the greater difference between them. So, well separated clusters. So, each point is closer to all the points in its cluster. So, now each point in this cluster is very much closer to every other point in the cluster, and it is not nearer to any other point into the another cluster. So, points in these clusters are similar to this cluster only, and points in this cluster are similar to this cluster only. Points in this cluster are not related to this, and the points in this are not related to this one. These type of the clusters are called as well separated clusters. Next, coming to the second, center based or prototype based cluster. A cluster is a set of objects such that an object is a cluster. Object in a cluster is closer to the center of the cluster than to the center of the any other cluster. So, every object, every point into this particular cluster is closer to the center of the cluster. So, here even though these two clusters are very much nearer to one another, even though these two clusters are having a very much nearer type of similarity, but here what happens, the points in this cluster are similar to the center of this cluster, and they are different from this cluster. The center of the cluster is also called as the centroid. So, now if you take any one cluster, so all the points in this cluster are arranged or find out or how they are being called as similar. So, we will take a centroid of the cluster and we will take all the points nearer to that cluster will be grouped into that cluster. Okay, that the average of all the points in the cluster, or that is also called as midpoint, the most representative point of the cluster. So, in center based or prototype based cluster, we will consider a concept called as centroid or midpoint, the most representative point of the cluster. So, all the points into a particular cluster will be very much closer to that thing. So, center based cluster, each point in the points is closer to the center of its cluster than to the center of the any other cluster. So, point in this cluster should not be similar to the points in this cluster or center of this cluster. Next, coming to the contiguous cluster or a graph based cluster. A graph is a set of the points such that points in the cluster is closer or more similar to one or more other points in the cluster than to any point not in the cluster. So, now what it says, cluster is a set of points, such that point in a cluster is closer to one or more other points in the cluster than to any point not in the cluster. So, all the points So, here the points in the cluster should be similar to one another. Okay, so, the points in this cluster may have some bit of similarity with respect to this, but they are very much different to with respect to this cluster. So, each point is closer to at least one point in its cluster than to any point in the other cluster. So, each point is closer to at least one point in its own cluster than to any other point into the another cluster. So, that is contiguous, means neighboring, side by side, that is nothing but contiguous. Next, coming to the another concept, another type of the clustering called as density based clustering. A cluster is nothing but a dense region of the point. What is a cluster? Cluster can also be defined as a dense region of the points, means the points are very much densely put into the cluster, means all those clusters, all those points are grouped into one cluster which are having similar properties. A cluster is a dense region of the points which is separated by low density regions from other regions of high density. So, now you can see these are the regions of high density, these are the regions of high density, these are the regions of the high density. Okay, a cluster is a dense region of the point. So, here the clusters in this point, the points in this cluster are very much denser, and here they are less dense, but even all these points in this cluster are very much nearer to one another, all the points in this cluster are very much nearer to one another, and all the points in this cluster are also very much nearer to one another, but here the points in this part are very much densely closely related to one another as compared to these two clusters. Used when, so when we use the density based cluster, when the clusters are irregular, or intertwined, or when the presence of noise is present, or when the presence of outliers are present. Outliers means nearby points to the particular cluster, then we use density based cluster. So, now next coming to the another part called as shade property or conceptual cluster. So, find the cluster that shares some common property to represent a particular concept. So, now here shade property means two clusters, some points of the two clusters share a common property, means consider for example this area or this area, where there is in this area the points in the cluster, they share a common property. Okay, so to represent a particular concept. So, even though these cluster points are different from these cluster, but some points in this cluster and some points of this cluster, some points of this cluster and some points of this cluster share a common property. So, points in a cluster share some general property that derive from the entire set of the points. Okay, next coming to the one of the most important type of the clustering algorithm, that is called as k-means clustering. Okay, so what is a k-means clustering? K-means is a partitional clustering approach. We have two types of the clustering approaches. One is partitional based and one more is hierarchical based. So, k-means algorithm or k-means clustering is a partitional clustering approach, wherein each object, each points, all the points in the group are arranged based on their similarity, and the points which are not similar to one another, they are put into the other cluster. Each cluster is associated with a centroid or the center point. So, in k-means clustering algorithm, so whenever you group a particular cluster, so first take a cluster, find out the centroid of that cluster, and once you find the centroid of that cluster, all the points near to that cluster or all the points which are having similarity with respect to that centroid, then all those points will be arranged into that particular cluster. So, each point is assigned to the cluster with the closest centroid, means each point will be into, or each point will be placed into a one group, or a particular point will be placed into a one group only when it is closest to the centroid. Then number of clusters, that k must be specified. K means one is clustering, k means nothing but it is a number, how many number of clusters you want to have. So, here if k equal to 1 means there is only one cluster. If k is equal to 5 means there are 5 different clusters, where you have 5 different groups, wherein each group is having n number of the points, and each points in a particular group share a common properties, and each cluster is different from one another. So, whenever you are deriving k-means clustering algorithm, whenever you are applying, so you need to specify the total number of the points, so the total number of objects into how many number of groups you want to, or how many number of clusters you want to divide them. So, what the clustering algorithm says, first one is, it is a clustering partitional based clustering approach. So, each cluster is associated with a centroid, or we call it as a center point. Each point is assigned to a cluster with the closest of the centroid, and here, so whenever you are applying k-means clustering algorithm, then k must be specified. Then what is this say? First one is, select k points as the center as the initial centroids. So, select k points as, so if k is equal to 5, take 5 points as the initial centroids, then go on repeating until you form k number of clusters. So, each cluster will have some objects, and all the objects in that cluster are closest to the centroid, which are similar to the objects present into the group and different from the other group. So, form k cluster by assigning all points closest to the centroid. Recompute the centroid of each cluster. Now, go on repeating this. So, every time once you form a cluster, so once you form a group, then what do? You recompute it again. So, again, so that all the objects that come into the closure, so all the objects that come into the closure, so that all the objects in a particular cluster are very much similar to one another. So, it should not happen that an object that having a different property comes into this group until the centroids do not change. So, this process you have to go on doing until the centroid do not change. So, now how we start with the k-means algorithm? So, initially what we do? Initially we choose a centroid randomly. Okay, what we do? We choose the centroid point randomly. Take any one point in the cluster, any one point as a centroid, randomly you select, then all the points that are similar nearer to that particular centroid, okay, assign into the one group. So, cluster produced may vary from one run to the another run. So, we need to run this k-means algorithm multiple number of times, because I need to find out the objects that are similar to one another. So, clusters produced may vary from one run to another. So, in first run you may have 10 clusters, in second run you may have 8 clusters, and in third run you may have 5 clusters, because of change in the centroid, so that objects that belong to a particular cluster should come to that group only. That should not, one object should not, or one point should not be a part of multiple clusters. The centroid is, what is a centroid? Centroid is typically the mean of the points in the cluster. So, you take all the points into the cluster, take a mean of that, that is nothing but the centroid. So, now here closeness. So, now how you define the two objects or 2 points in the cluster are nearer to one another? So, based on what property? How you say that 2 points into the object are nearer to one another, or how you say that 2 points are similar to one another? So, here in order to measure the similarity between the objects, one way is, that is closeness. How you measure the closeness between the 2 points in a cluster? That is by using an Euclidean distance, or you can use cosine similarity, or you can use correlation. Different properties or different methods are available. You can adopt any one of the method which is feasible based on what type of objects are using, based on the application. You can choose any one of the method, either you can select Euclidean distance, or you can use cosine similarity, or you can use correlation. So, k-means algorithm will converge for common similarity measure mentioned above. So, what we do in a k-means algorithm? So, k-means algorithm will be using a common similarity measure. So, most of the convergence happens in the first little iteration only. So, in k-means algorithm, the basic advantage, the most important thing of the k-means algorithm, most of the convergence happens in first iteration only. So, most of the clusters are, or most of the times the centroid whatever you form in the first run will remain as it is. Often the stopping condition is changed until relatively few points change clusters. So, now I should not run this clustering algorithm for the huge number of times. I cannot run it for 10 number of times or 20 times or 30 times. There should be some limitation. So, when should I stop forming the cluster? So, when less number of the points change their cluster. So, consider for example, if one point, so consider for example, only one point in one cluster group 1 changes to group 2, then at that time you can stop doing this condition. Then what is the complexity? What is the complexity of the k-means algorithm? So, you are saying we need to find out the centroid, we need to find out the Euclidean distance, you need to find out the similarity, and you need to run the k-means algorithm for the multiple number of times. Then what is the complexity involved in this? How much amount of time is required? Whether it is more time consuming or whether it is more complex. So, complexity of the k-means algorithm is O. O defines the complexity of the algorithm, n into k into I into d. So, what is n? N is the number of points. How many number of points you have? That also defines the complexity of the algorithm. If the number of points are more, complexity will be more. K is equal to the number of the clusters. So, how many number of clusters you want to form? Whether you want to form 4 number of clusters, 5 clusters or 10 clusters. So, if more number of cluster, more complexity again here. Then I equal to number of iterations. For how many number of times you want to run the algorithm. So, that also an important factor that affects the complexity of the algorithm. Then D, how many number of attributes you are going to consider for a particular point. What is an attribute? A property of a particular object. So, if you take a student, what are the attributes associated with the student? Your name, okay, your university number, okay, your department, your roll number, your semester, all these points are nothing but the attributes. Similarly, whenever you take a point, okay, so for that point we need to take out the number of attributes also. That also defines the complexity of the clustering algorithm. Next, how to evaluate clustering algorithm. So, evaluating k-means clustering algorithm. So, now how efficiently your clustering algorithm is working out. So, whether the performance of the clustering algorithm is good or no. So, evaluation for how much it is effective. So, if you want to evaluate the k-means clustering algorithm, so the most common measure is sum of squared error, SSE we will use. Okay. So, for each point the error is the distance to the nearest cluster. So, now here error, what is an error? So, here for each point the error is the distance to the nearest cluster. So, consider if you have one point into the one cluster, at how much distance it is away from the another cluster, how much it is away from the another cluster. So, if it is nearer, then that is an error. So, one point, an object in one cluster should not be similar to the object into the other cluster. Okay. So, here if the distance between if the distance is very large, means an object is too much away from the other cluster, then you have performed, or your k-means clustering, or your performance of the k-means clustering algorithm is very good. So, to get an SSE, we square these errors and sum them. For example, SSE is equal to summation I equal to 1 to k, k is nothing but the number of the clusters. X belongs to C of I distance square. So, here we are measuring, we are using the Euclidean distance. So, take one point into a group and measure with it is the nearest distance. So, what is that distance? That distance is nothing but the Euclidean distance square m of I comma x. So, what is x here? X is a data point in the cluster C of I. So, here take any one cluster C of I. What is C of I? What is x? X is a data point in the cluster C of I. And what is m of I? M of I is the representative point of a cluster C of I, and can show that mi correspond to the center or mean of the cluster. So, mi is nothing but the mean of the cluster. So, given two clusters, we can choose the one with the smallest error. So, when you take one object, you take one object, okay, measure with the different two clusters, and you need to select one cluster with the smallest error. Okay, so, one easy way to reduce SSA is to increase the number of the clusters. So, how you need to reduce? How we need to reduce the sum squared error? So, one way is to increase the k. So, if the number of clusters are more, then there are less chances of having a one object similar to the other objects. Okay, a good clustering with smaller k can have a lower SSE than a poor clustering with a higher k. So, now what has happened? A good clustering with a smaller k value can have lower SSE than a poor clustering with a higher k. Problem with the selecting initial point. So, next point is what are the problems with selecting the initial points. So, how I need to select the initial point? What problems we will face? If there are k real clusters, then the chance of selecting one centroid from each cluster is small. If there are k real clusters, then the chance of selecting one centroid from each cluster is small. So, chance is relatively small when k is large. So, if a clusters are the same size n, then what is the p? Probability p is equal to number of ways to select one centroid from each cluster divided by number of ways to select k centroids, that is equal to k factorial n raised to k divided by k into n raised to k is equal to k factorial divided by k raised to k. Okay, for example, if I apply this formula, if for example, if k equal to 10, then what is the probability? Then probability 10 factorial divided by 1 of 1010, that is equal to 0.00036. Sometimes the initial centroid will adjust themselves in the right way and sometimes they do not. Okay, so dear students, okay, so we will stop onto this point. This is enough for this video lecture. The rest of the part I will continue in the next video lectures. Thank you.